Hello YouTubers, welcome to part 5 of this series. Let's check what we'll cover in this video. So we'll set up our basic fall state and also deep dive into camera setup with the plugin that we downloaded. So the table of content for this video will be fall state behaviors for both active and inactive states, fixing movement issues that we get, and then set up our camera with multiple different states and multiple angles, and finally testing all the stuff that we just created. Alright, so the prerequisite for this video are knowledge of phantom camera, so it's moderate, and it's better to have some knowledge about what phantom camera is, how it works, and also some basic scripting of states. So the level is again moderate, and my video on cool camera effects, so it's a must watch, so you have some more understanding of how cool effects can be made using just a camera. Alright, so the previous recap was in my last video we implemented aim states, added dodge functionality, and started to debug our scripts. So if you did not watch the video, then please do it before going further. So now it's time to add the logic for our fall state. So to add the logic, we either need to travel from inactive to fall, or maybe from active or aim to fall. So let's write the script inside our inactive and let's create a function for that. So let's slightly zoom in, and the function name will be fall. So inside this function we need to have a variable to keep track of whether we are falling or not, and if we don't fall, then we don't enter our fall state. So let's quickly create a variable, call it as is falling, that will be set to false, and let's copy the same function, and whenever we enter our inactive state we just set the variable to false so that we know we are currently not falling. Okay, and now let's say if not.agent is on floor and we are not currently falling, then we need to fall. And by the way, what is this is on flow? Well, this is a function that comes with our character body 3D to check whether the character body 3D is on floor or not. So this is an Godot inbuilt function. So now if we are not on the floor, that means yes, we are falling. So we set our falling to true and we just wait for few seconds. To wait for few seconds, let's create a timer. So get tree, create a timer for 0.2 seconds, and if this timer is out, then we need to travel to fall state. So you may again ask, hey, why do we need to create a timer when we already know that we are not on flow and we are falling? So the reason is because maybe let's say your player is moving on a ground, and let's create one more ground by pressing Ctrl D, and let's move it something like this. So maybe this is a small step, or maybe you find any of the objects on the ground, maybe you have some rocks, or maybe your ground is not evenly flat. So at some time you may have a slight a step, or maybe anything like to say that ground is not flat. So at that time it will automatically get this event triggered, and once this condition is triggered, your player will play the whole animation of falling from a very height. So that's basically playing this and then playing this fall to land, even though this gap was very low. So to avoid that kind of issues, we just create a small timer to check if our player is actually falling, or the player was trying to move on a uneven surface. So that's why we just create a small timer, and then after this timer, if again our player is not on floor, then we need to change our state. So we just call our change state from our agent, and we change from self to fall, and let's just cross check the event name. So we go from inactive to fall whenever we call this event. Okay, so we go from self to fall, so we call this event, and let's say that if not, then else, we just set our is falling to true, which means that is falling to false, which means that is player was not actually falling and he was just on an uneven ground. Okay, once this is done, now we need to call this function inside our update so that it can check for the falling state, and we need to write this same function in our active. So let's copy the same function and let's even paste it inside our aim, and this function actually requires the variable. So let's create a variable is falling set to false. Let's copy the same variable at enter. We just set this variable to false so that whenever we enter this state, we don't want our player to fall. So we'll do the same thing in our inactive. So we just have written that, and the same in our aim. Cool. So it's time to call this function inside the update of aim as well as the update of active. So now we have the way to enter to our false state, and inside this false state we actually need to write the logic to go back to any of the state, and before that it's time to create our enter as well as our exit function. So now, before actually thinking about going back to our inactive or active states, let's see what we need to do first. So first we need to travel to any of this state. So same as in this inactive, so how we have a state transition, similar way we need to transition to any of this state. But now the problem is that we have two different state names while we have just a single limbo state. So how do we know that either we need to travel to our this state or we need to travel to this state inside our animation tree? So to solve this problem, we have a built-in function inside this limbo HSM. So whenever we enter this false state, we can get our previous state from which we came. So if we came from inactive, then that function will return like, hey, we came from inactive. And if we came from active, then we'll know that we need to travel to our active. So to create that function, let's call get travel state. So this will determine which state we need to travel, and inside this we need to actually get the previous state that we are coming to determine our next state. So to get the previous state inside our root, let's just create a function get previous state, and this will return our limbo HSM. So as I said that limbo HSM has a function, so the name is get previous active state and its name, so it just returns the name of the state rather than the state. Okay, so it's time to call this function inside our fall. So variable last state will call our agent get previous state, and now we can match our last state. So if our last state is equal to inactive, then we know that we need to travel to our inactive fall. So if our last state it was in our active, then we travel to our active fall, and if none of these matches, maybe it's an aim or any other state, then we just travel to the active fall. So now we just got which state we need to travel. So we can create a variable, maybe call it as next state. So this will call our this function, and this will return that which state we need to travel. So now we can easily call this transition state, and the state will be our next state, because this will determine which state we need to travel. Cool. And now let's create a function to go back to our previous state. So inside our update, whenever we are on floor, then we need to travel back to our previous state, and before traveling, we need to actually play this fall to land animation, because whenever we enter, we just loop through this animation again and again, and once we reach the ground, we need to play this land animation, and then we can just travel back to our different state. So to trigger this animation to play, we need to actually write the code. And again, if you remember, then in the animation tree, we just wrote a code for substate transition. So why can't we use that? And the answer is like, this substate transition was mainly for our blend trees. So if you remember, then we just had this blend tree, and now it's an state machine inside a state machine. So we need to write a different function for that. We can't use the function because that was of blend tree, and this is for state machine. So now let's create a function, call it as direct substate transition, and this will actually require the name of the state. So either it's inactive fall or active fall. So let's create an argument, call it as maybe state name, that will be string, and then the second argument will be the name of the state that we need to trigger. So maybe let's call it as anim name, and this will again be type of string, and to travel any of the state, we need to get the playback. So for that, let's call the variable playback. This will be equal to our active fall playback. It's not required to be an active fall. So let's just cut the string out, and in between we will specify the name. So it can be an active fall or it can be an inactive fall, and we get its playback. So if the playback is successful, then we just call the playback dot travel function, and we need to travel to this animation name. Cool. Now we can just copy this function, and in the fall, whenever we are not on the floor, we can call this function agent dot animation tree. We call this function, we need to pass which state we are in, so we can call this function inside this function. So this will return which state it should trigger, and next the name of this animation, and that's fall to land. Cool. So once we play that animation, we can call our change state. So agent dot change state, and we need to change our state from self to a next state. So how do we again get our previous state? Well, again the same, using this same function get previous state, and from that we can actually get the event name of our limbo HSM. So let's create a function get or land travel next. So this, so variable last state equals to, we get our previous state, and then if either you can write a match or switch conditions, or you can write an if else. So if our previous state was inactive, then we return our to inactive event. If not, then we want to go towards our to active, because we can't go to aim. So either if it's inactive, then we go to our inactive state. If it's an active, or if it's an aim, then we need to travel to active. We can't go to aim because once we play the land animation, we can't make our player to draw the arrow, so we just revert it back to active. And for the confirmation, let's see the event names. So we go from fall to inactive whenever we call this to inactive, so that's the name here. And we can go from fall to active whenever we call this event name, and that's here. Cool. So now we can just call this function to change the state. Now that's most of the thing to play these animations and make back these transitions. So till now what we wrote, the code was only for traveling through animations. We actually also need to write our actual fall logic, because these states were only for the animation change. Now we need to actually change the velocity of the player to make him fall. So now to make the player fall, we need to write our code inside this process function. So the falling is something related to physics, so we write in physics process. And here if is not on flow, then we change our velocity dot y equals to, we change a gradual from its current value minus gravity times delta. And by the way, what is this gravity? It should be in constant that we need to create and set its value as 10. So either you can change the value according to your wish, how heavy the gravity you want to be. In my case, I'm just setting it as 10. And now the clamp value should be in between our minus gravity to plus gravity. And if the player is on flow, that means we no need to have the effect of gravity, so we set it velocity to 0. And here, if you remember previously, then just setting up the velocity doesn't make our player fall. We need to have call this move and slide to make our player fall. And if you see the code, then yes, here after setting the velocity, we actually call this move character. So instead of calling it twice, we can just call it once inside this physics process. So if you call this function again and again, then our player will have a very odd behavior. So we just call it inside this physics process rather than inside this move. That's everything. Even in the inactive, we can erase this move character, and it's time to see the actual working of our player fall. So let's run it now. And you can see, yes, the player is properly falling on the ground. Let's go to active Let's try to fall. Yes, it's working and even the movement is proper. Okay, let's have some different testing on this. So maybe even the dodge. So the last testing is with in the dodge. So let's go to active, let's try to dodge, and no, you see that the player is going somewhere else. And you see that we get a glitch over here. And what is that? Well, basically the player dodges and then he goes to this fall state, and then once again he goes from fall to active. The dodge animation resumes, so we don't want that. Whenever we change our state to fall, we need to stop all the one shots that we're currently playing, because the one shot is mainly responsible for the dodge, or the one shot is mainly responsible for this aim. So we need to stop both of these one shots, as well as we need to set this movement values to 0. So for that, inside this animation tree, let's create a function reset movement, and inside this function we need to call our this current blend position, as well as this cursor blend position to 0. So I'll just copy this. I'll set our current blend position to vector 2.0, and also we need to stop our one shot. So similar to this set one shot active, we can just say set one shot abort. Well, abort basically means we need to stop a one shot without further playing. So let's call the abort, and now let's call this set one shot abort for both our dodge OS as well as this aim OS. And we need to call this reset movement in our fall. So whenever we enter our fall state, we just call this reset movement of our animation tree, and whenever we enter our fall state, we just call this function. So this function will again trigger this reset movement. So I think now the issue should be gone. So now it's time to add some script for our camera. So if we run our game now, and you can see that the camera is at a single point, like it doesn't move when our player tries to run, or whenever our player is walking slow, the camera doesn't have any movement. And this looks very odd, because if you have watched my video on some of the camera tips, then you'll see that if we make our camera still, then the game looks boring. So what we will basically do is, maybe we will add some different kinds of states for our camera, so that whenever our player is active or shooting the arrow, the camera will be moved towards the shoulder of our player, or maybe whenever we try to run, the camera will be far behind the player, and if we are at the walking state or at idle, the camera will be in a different position. Cool. So to add all those script, we will be basically writing the complete logic inside our camera manager. So inside this, so now let me just clear the space up. So at first we will create few states that our camera will have. So to create the states, we will use enum and then create a variable called camera states. So this will have 4 different states that our camera will move. So the first one will be walk, then we have run, then we have active, and the last is fire. So that we don't have confusion, I just named this as fire. And these are the 4 different states that I want to have in this controller. And maybe in future, if you have developed some different kind of controller, then you can just have more number of states. That's fine. And other than this, let's create a couple of variables. So So now I have created this 6 variables. So position, that will store vector 3, spring arm, FOV, horizontal vertical offset, and current state, that determines which state we are in. And then one more variable, so that's the transition speed of our camera when the camera moves from one state to another. That's fine. And now let's see why exactly I have created these variables. So if you select the main camera and if you open up this bottom section of phantom camera, you will see that couple of properties in the inspector, and the follow offset changes the position of the camera. So it is a vector 3. By the way, we'll just be using this y offset and not other things, but I just added this as vector 3. That's fine. And we have this spring arm length for having a zoom in effect. Other than that, if you open up the camera resources, then you will see that we have this horizontal offset, vertical offset, and FOV. So FOV basically tries to focus on an object, and we'll be storing all these values inside this. So it will not be just storing, but it will be for a temporary storage that we will use whenever we change these states. So now you may have few questions, and that's basically like, hey, we have this follow offset x and y and z, then why do we need this horizontal as well as vertical offset? Because for the horizontal offset, this x value is acting the same, and the same goes for the vertical offset, you can see. And also this FOV, so the spring arm acts as the same. So let me just clarify the difference between HV offset along with this follow offset. So let me open up my paint. So here let's imagine that this is our player and this is his forward direction that he's facing. So this will be the back of our player. So now let's say that currently our player is in walk state. So at that time we want our camera to be backside of the player, somewhere over here. And now this will be origin of our camera, and this is all the stuff that our camera can see. So normally there is no problem with this, but let's say that we try to rotate our camera 90 degrees along with the player. So this time the player will be facing in this direction, so this will be the back of our player, and our camera will go somewhere over here. So this is fine, because when we were at this point, the camera was facing in this direction, that's basically back of our player. And when we rotated 90 degrees, again the camera is facing the back of our player. That's fine. So the center of origin is here, so based on this, the camera rotation has taken place, something like this. And if you continue more, then the camera will be trying to rotate around the player in a circular manner. That's fine. And by the way, just ignore that I haven't drawn a perfect circle. So now let's imagine one more use case, or let's say that our player goes from walk to aim. So at that time, we want our player camera to be here. That's basically at the shoulder of our player. So at this time, where do you think the origin of our camera should be? So when it was in the walk, the origin was here. So now if we try to change, this X offset, then the origin will be at this point. And whenever the origin is at this point, we'll have some serious issues. So what are those? So again, let's say we just rotate our camera 90 degrees. So this time the player will be facing in this direction, and this will be the back of our player. So our player has rotated on his own axis. That's fine. But for camera, the origin was here. So this was the camera previously, and now since it has rotated 90 degrees, the camera will be at this point because this was the origin that we had. So now you can see that the camera is at back of our player. At this point the camera was at the shoulder, but now the camera is at back of our player, and we don't want that. So whenever we are trying to move, we want our camera to be always at the shoulder point instead of here. So follow offset does not help us to solve these problems that I have just explained. So to solve this, we can use horizontal as well as vertical offset. So let me just show you. So now you can see that whenever we try to move the follow offset, the camera is moving in our 3D scene. But whenever we try to move horizontal or vertical offset, you can see at this screen the camera is moving, but in reality it's not moving. So we can use this vertical as well as horizontal offset to fix the origin issue that we had. Okay, and the FOV acts as a point of focus. So whenever we are focusing on any point, that means whenever we are trying to shoot arrows, we'll reduce the FOV, and if not, that means we are not shooting any arrow, then the FOV will be as 75. That's okay. So now, since I have explained all these stuff what it will be doing, and the variable that's camera transition speed will change the camera position from one state to another with this many times of second. So now let's create a function that can change the state of our camera. Let's create a function, call it as set camera position value. So this will take the argument to which position we want to change our camera, and the argument will be camera states. So basically, if we want to change our camera state to let's say camera.walk, then we'll just set all these values to walk state. And if you want our camera to move towards run, then we'll change all these values to run. So I'll be showing you what exactly I mean. So let's match our two state. So let's say if our two state matches camera dot walk, then at this section we'll set all these values, and if not it matches to run, then again the same thing. Let's also write active as well as fire. If none of the states match, then again a condition for that. By the way, this will not work because the argument that we get should be in the camera states that we define here. So this is just an extra condition in future if you add some of the other states, or just to avoid any flow leakage. Okay, so whenever we have changed to a different state, the first thing that we need to update is our state, this variable current state. So let's just reassign our state. So whenever we are in walk state, we assign our current state to be walk, and whenever we are in run, we just reassign its state. And if none of this matches, then we just set it as null. Now let's try to change the experimental values for each of the state. So for that, let me just copy this, and I think it's better to rewrite all these stuff. So position equals to vector 3, then we have spring arm, then we have FOV, next we have horizontal offset, vertical offset, and let's see. Okay, so let's open up the phantom camera, and now let's change the spring arm length. Also, I think we need to slightly change the camera angle. Okay, so this is good, I guess, or let's slightly do it here. Okay, so the origin point will be somewhere lower, or let it be 0, and this is fine, I guess. So again, all these values are experimental values. You need to tweak until you see that our current camera is looking fine. So make sure you tweak the changes if you don't like your current camera. And these are not the default values, or these are the not exact values that you need to have, so it can change according to your wish. Okay, so the position will be storing this follow offset. So the x and y are basically 0, and the x and z values are 0. So for y value it's 1.505, the spring arm length is 1.17, FOV is set to 75 because we don't change FOV, and horizontal offset, vertical offset are zeros. And by the way, if you say like, hey, when you're not changing FOV, then why do you write here? So maybe in future, let's say we were in aim and we just changed it to walk, or maybe we were in active and then we just changed our state to walk. At that time, we also need to reset our FOV. So even though the default value is FOV, we again need to reassign that value. Same case for horizontal and vertical offset. And here, I think we can also change this min and max pitch. So how how much our camera can rotate. So whenever we are in active and fire state, we'll just clamp the camera value rotation to a lower, so that we can't see at higher axis. And whenever we are in normally walk and run, we can have the freedom to make our camera rotate at great angle. That's okay. So the min pitch, let it be 50, the max pitch, let it be minus 90. So I think this was the default value that we created. And if you have something like 89, or just make it as 90, round off. And now once we set all our temporary variables, we can just return true. That means this was successful. And we'll do the same thing for our run. So let's copy this stuff, let's paste it here, and this time we also need to change the values. So whenever we try to run, And by the way, just remember that I'm not, changing the vertical value rotation somewhere here. So if you want to have some different angles, then you can create a variable for that. But in this case, I'm not using that. And for run, the follow offset is 1.48. The spring arm length is 1.91, and other stuff are same. So let's also return true in this run. And now in active, let's paste the same stuff. And whenever we are at active, as I said, I want the camera, to be focused on the player's shoulder, not exactly shoulder, but maybe we'll just change our play position to be somewhere here. So the object is at right. So let's see. Let's also change the FOV to something 65. Okay, that's cool. So now let's just enter all these stuff. So the FOV will be 65, the spring arm length will be 1.565, and the horizontal offset is 1.035. There is no change in the vertical offset. FOV has been changed. Let's also change this min and max pitch. So whenever we are in active, the camera is locked so that the player has no freedom of complete rotations. So maybe the max pitch 25, the min pitch is again minus 25, and then we also return true. And other than this, I think we can also change the mouse sensitivity. So whenever we are in the walk, we have our mouse sensitivity set to its default value, that's 0.2, and whenever we are in the run, the mouse sensitivity is 0.2. but whenever, let's say, we are in active, we just reduce the mouse sensitivity so that player can have more focus on shooting the arrows. And in the fire, I think it's optional, but you can also try to reduce it, so maybe 0.08. and let's copy this same stuff. And now let's again change the FOV value to maybe 35 and change the spring arm length. So let's quickly enter all these values. And at last, whenever we set these values, we can return true. And if none of these cases are true, then we can return false. That's cool. So now we can actually create a function that we can call whenever we want to change our camera. So let's rename it as change camera, and here the argument will be to value that will specify what camera state we need to have. So let's pass this argument here. So whenever we call this function, we also specify which state we need to travel, and here we can call our set camera position with our value. So we need to only set our camera position when we change our states. So basically, if we are in this walk state and we just call this function, so we don't want to again reset the same value again and again. So instead of that, first we need to check if our current state is equal to that value. So if it's not equal, then we can go ahead and change to a new state. So for that, let's create a function again, our different state. So this will have an argument of that state. So if our current state is not equal to the state that we specify, so this will return like, hey, if we are in our current state and do we need to change the value. So if not, then we don't change our value again and again. So if we are in a different state, then we need to change the value. So at that time we set our values before changing, and once we set our values, we can try to change our value using a tween. So let's say get tree, create tween, and here we can set parallel to true. We can also set the ease in values, so set ease So now this is a single line code. It's not splitted into two different lines. I just pressed Alt Z. Okay, so here we just define what type of easing we want and also what type of transition we want. So if you don't know how to use a tween, please go and check a video. There are a lot of videos available on what exactly the tween do. But for short, tween will be helpful for changing these values in a gradual way rather than sudden shifting our camera states. We will have a smoother camera movement, so that's why we just use this tween. And here we can call a property on this tween, so tween property, and we want to call it on our main camera. So our main camera is this one, so this will be as I said, that main camera, and all these properties are based on that. So in our tween property, the object is main camera, and what do we change in that? Well, basically we need to change its horizontal offset value with the variable that we have, along with the transition time that we specified. So let's duplicate it a few more times. So the first we change our horizontal offset, then we change our vertical offset with the variable that we have. Then let's also change the follow offset with the position variable that we have. Also change the spring length. So basically the variable name is spring length, not spring arm. So let's change the spring length with our variable spring arm. Then we can change the FOV with the FOV variable we have. And how many variables do we have? So it's basically 1 2 3 4 5. Okay, so the last line is not needed. Now that's it for setting up our camera states. So we can call this function from various different states, and then we can specify which state we need to travel. So we'll be calling this function from our active states. So as I said, we can't directly call a function from a different node that's equivalent. So first we need to create the reference in our root node. So let's create onready var main camera, or let's call it as camera manager. That will be the node of our camera manager. And now in this inactive, whenever we try to enter our inactive state, we can call agent camera manager dot change camera, and here we can specify which state we want to travel. So the enum name is camera state. So inside the camera state, we specify our enum value with the state. Okay, so whenever we enter our walk state, we set our camera to go to walk state. Whenever we are in the active, we set our camera state to be active. Whenever we are in the aim, we set our camera state to fire. So here we don't specify as aim because that's what the state that we have created, it was fire. So we specify as fire. And also if we are in the aim and we try to fall, so if we change our state to fall, then we can also set the value. So we can say that whenever we try to fall, we change our camera state to be, let's say, active, because whenever we land from the aim state we go back to active state, so we just specify the transition to be active. And finally, I just forgot that we also need to change our camera state whenever we are running. So in the should run, in our inactive script, we just change our camera state to be run, and if we are not running, then in the else block, whenever we return false, we just change our camera state to walk. Okay, that's fine. Now it's time to test, and we get an error. So the error is camera manager is not defined. By the way, yes, this is camera manager instead of main manager. Now let's try. And yes, there is a bug. So what is that? So the camera is not actually working properly. And yes, the issue is like the min and the max pitch is reversed over here. So the minimum pitch should be minus 90, max pitch should be 50. The same thing goes here, and the max minimum pitch should be minus, the max pitch is always positive. Okay, so let's try it now. And yes, whenever we try to run, the camera is going back from the player. And let's go to active. Yes, this is working great. And let's try to shoot the arrows, and you can see that the camera states are working fine. So whenever we fall again, we go back to the active state. That's fine. So everything is working as expected. So if you don't like the setup values of the camera, you can tweak again. I have shown you how to tweak the values and then how to assign those values in our match condition. And if you are worried about player is not exactly facing in the direction, he's just facing his bow towards the left tilt, that's okay, we'll fix that. But I think this is working fine. So whenever we try to aim, the camera has a cool visual effect that says we are zooming in a lot, but in reality that's not the case. So this is how the FOV works. So the FOV really helps us to add that visually zooming in effect that we created. And that's it for this controller of camera manager. Now it's time to see all the scripts that we have made. So that's it in this part. So let's now see what all progress we made in our video. So we added a false state reactions for both active and inactive states, fixed some movement bugs, and then created multiple camera states and tried to test them with different camera placements. And also we tried to explore the phantom camera features, what all it provides. Before we wrap up, if you enjoyed this video, then don't forget to hit like, drop a comment, and also subscribe for more future content. And if you'd like to go with an extra mile in supporting me, then you can just grab the potato card membership on my itch.io for just 1 USD. Every bit of this support really helps me for keep me creating more stuff and improving for you guys. Thanks for watching, and I'll see you in the next one.